The sa12v140 engine has been developed over the past few years to meet the demand for larger construction machinery and has demonstrated excellent results in various parts of the world in a variety of work applications. Here are the main specifications of the sa12v140 engine, renowned for its high output, low noise, low fuel consumption, and high reliability. The key points on assembly, disassembly, and performance inspection of this engine will be introduced in this video. The application of this engine varies with the models on which it is mounted. Here are the D475A-2 bulldozer specifications. Now, those of the HD 785-3 dump truck. And finally, the specifications of the WA 800-2 wheel loader. As shown on this flow chart, the engine overhaul consists of several procedures, with the key points of each procedure introduced here. On receiving the engine, check for any missing or damaged parts and photograph the state of the engine. Since engine oil, filters, and defective parts are required for the subsequent troubleshooting, mark the engine serial number and service meter on them before storage. Although the engine can be disassembled as installed on a unit repair stand, it can also be disassembled as installed on a simplified stand by removing the oil pan. Special tool disposable parts used for these engines are as follows and are introduced when used. The disassembly and assembly procedures introduced in this video differ slightly from those in the shop manual. This video shows the procedures of engines specified for the WA 800-2. Remove the alternator, drive pulley, and drive shaft. Then, remove the fan belt by inserting a crowbar. Mask the turbo and aftercooler to prevent entry of dust. Mask the aftercooler. Mark the aftercooler to identify its assembly position to the harness bracket for subsequent reassembly. Take care not to damage the ceramic air heater when removing the aftercooler. After the fuel pipe, fuel pump, and spill tube are removed, mask the openings to prevent the entry of dust. The fuel pump is removed by marking the coupling, removing the coupling bolts, loosening the bracket mounting bolts, tilting the fuel pump together with the mounting bracket, and removing the fuel pump mounting bolts. The mounting bracket features dowel pins. The fuel pump coupling is removed by inserting a screwdriver to the slit. The exhaust manifold is marked and then removed. After removing the manifold, mask the opening. Remove the air compressor. Remove the water pump. Next, remove the oil cooler. Then, remove the air breather. Before removing the rocker arm, loosen the lock nuts and return the screw to release valve spring tension. When removing the nozzle holder, first remove the fuel connection and remove the holder. Then, remove the nozzle by using the holder like this. For number 5 and 6 nozzles on the HD 785-3, there is no upper space, so a puller, such as the one indicated, is used. Mark the position for future identification or for failure analysis. Mark the number on the cylinder head and rocker case. For reference, as viewed from the flywheel side, the cylinders at the right are called the right bank, and those at the left bank. These cylinders are numbered 1, 2, 3, and so on, in order from the fan side. Remove the rocker case, push rod, and crosshead. Mark the push rod and crosshead. Remove the head. Remove the valve using a spring pusher. When removing the cotter, use a magnet to facilitate removal. Fasten a tag to the valve to mark the fitting position. Cracking of the cylinder head is checked by die penetration. Cracking is checked by washing with a cleansing liquid, then spraying on a penetrating solution, leaving it for a few minutes, wiping it off, washing, and finally spraying developing solution over the head. Since the cam follower mounting bolts are of a special type featuring a machined oil hole, store them carefully until reassembly of the cam follower. Be sure to mark the cylinder number on the cam follower. When removing the damper, place a detent on the flywheel and then insert a guide stud to remove the damper. Remove the thermostat case. The flywheel is removed by using a guide stud and inserting a pulling bolt. Remove the oil pan. Place the engine on a simplified stand. This is the sling for the block. The flywheel housing is removed by using a guide stud and by striking the housing with a plastic hammer. The gear case cover is also removed by using a guide stud. Measure any end play before the camshaft is removed, in order to check the amount of wear on the thrust plate in advance. Check the protrusion of the cylinder liner. Press down the liner with a plate to measure the protrusion using a depth gauge. After marking the cam gear, avoid damaging the cam bushing. Remove the camshaft by rotating it. After marking the fuel pump gears, use a gear puller to remove the gears. Remove the gear case. Before removing the crankshaft, measure any end play. Measure the side clearance of the connecting rod. Remove the piston cooling nozzle. Use sandpaper to remove carbon buildup from the liner top wall. Use a push bar to remove the piston. Mark the connecting rods, caps, and bearings with the cylinder number. Disassemble the piston assembly. Then, pull out the piston pin. Use a piston ring expander to remove the piston rings. Remove the connecting rod bearings and mark them. Before removing the crankshaft, measure the rotational torque as a guide when assembling. Use an 8x power wrench to remove the main bearing cap bolts. Loosen the bolts from the outside to the inside. Store the caps together with the bearings by cylinder number. Mark the liner position, and then use the special tool to pull out the liner. The reusability of each part is checked according to the shop manual maintenance standards or the Parts and Unit Evaluation Worksheet. Use the guidance for reusable parts also for checking reusability of parts. Parts unsuitable for reuse are marked with an X, for example. The oil cooler of a seized engine cannot be reused because its element becomes clogged with metal pieces. Replace with a new oil cooler. Parts are rust prevention treated and are stored in a low dust environment in good condition. Avoid stacking or piling parts as they may become damaged. Because parts ordering is an important point in reducing repair time, parts must be ordered at as early a stage as possible. Improved parts are introduced in the Parts and Service News, so refer to it periodically. Take care when ordering oversized pistons, piston rings, valve sheet inserts, head gaskets, and undersized or oversized bearings. Parts cleaning is an important aspect of repair. Before washing the cylinder block, remove the oil line and water line plugs from the cylinder block. As a guide, block cleaning takes about 4 hours by a skilled mechanic. Use a bristle brush to clean all the oil holes. Clean the aftercooler. Take out the core and clean the interior and exterior of the aftercooler with a steam cleaner. Disassemble the main relief valve, regulator valves, and oil cooler bypass valve for washing. Plugs are coated with Loctite and driven in straight with a proper push tool. Plugs driven in off-center will cause leakage of oil or water. Check grooves of the crevice seal and O-ring for pitching and burrs. Certain flaws can cause water leakage. Install crevice seals with the chamfer side facing downwards. Install O-rings. Insert a round bar and rotate it to eliminate torsion from the O-rings. Check the counterbore working face of the liner for abnormal wear or pitching. Apply LG6 to the corner of the counterbore portion. Coating is to be 2 to 3 millimeters thick and to overlap the corner of the counterbore by 0 to 12 millimeters. Coat the liner O-ring and crevice seal with clean engine oil just before installing the liner. The rubber portion expands with time, which may result in difficult installation. Likewise, Check the working face of the block seals for flaws and burrs, and then coat the face with engine oil. Align the liner identification marks and insert the liner by hand. If the liner cannot be inserted smoothly, the seal may become damaged, so remove the liner and inspect the seal. Drive in the liner. Wipe off any surplus liquid gasket coated on the counterbore by using a used gasket. Tighten the cylinder head. Remove the head and wipe off any LG6 run. Failure to wipe off LG6 run will distort the gammer grommet, leading to water leakage. Press down the liner with a plate and measure the protrusion. Take special care with the number 4 bearing, as it has a width of 52 millimeters, which is 4 millimeters wider than other bearings. Install the main bearings in the cylinder block. Wipe off any dust from the back of the bearings on the mounting face of the block side prior to installation. The oil hole should face the block side. Install the bearings by pushing them in the forward direction to avoid damaging them. Likewise, install a thrust bearing on number 7. The oil groove should face the crankshaft side. Blow compressed air over the screw holes on the rear front and oil holes on the bearing working faces to ensure that they are free from flaws and dust. Then, coat them with engine oil. Install the crankshaft. Install the main bearing in the cap. Wipe off dust from the back of the bearing on the cap mounting face prior to installation. Use a guide stud to install the cap. Check the cap number stamp, position the cap part number cast face to the front of the engine, and then align the bearing tang. Coat the main cap bolt threads and hard washers with engine oil, and then tighten the cap bolts lightly by hand. After tightening the cap bolts to 29 kilogram meter the first time and to 58 kilogram meter the second time, Mark them with paint. Then, use an 8 times power wrench to tighten the bolts at an angle of 90 to 120 degrees. The tightening order is from the center to the outside. Punch the bolts each time they are tightened, and replace the bolts with new ones after the 5th punch mark. Check that the crankshaft rotates smoothly. Measure the end play of the crankshaft. Install the oil, second and top rings in that order in the pistons. Turn the ring stamp mark upwards and position the joint of the oil ring expander to the opposite side to the ring gap. Check that the ring groove is free from flaws and that the ring rotates smoothly. Since a groove wear gauge is provided for the piston ring, make use of it to monitor the amount of wear. Check that the snap rings at both sides of the piston pin are set securely. Note that there are 2 connecting rods, the left and the right. Wipe off any dust on the back of the connecting rod bearing and mounting face to check that the bearing oil hole and connecting rod oil hole are in alignment. Then, install the bearing. Turn the block sideways, coat the inside of the liners with engine oil, check the piston connecting rod number, and then insert the piston. Position the chamfer side of the connecting rods to the weight side of the crankshaft. Take care regarding the notch direction of the cooling nozzle. Set the ring gap positions as indicated here. Coat the piston rings with engine oil, compress the rings with a piston holder, and push the piston in with a wooden hammer. Use a pull bar to help pull the connecting rod. Coat the bearings, bolts, screws, and hard washers with engine oil. Tighten the cap bolts to 7 to 8 kg-meter the first time, and to an angle of 90 to 120 degrees the second time. As with the main cap bolts, punch a mark on the cap bolts each time they are tightened. The bolts should be replaced with new ones after 5 punch marks. Measure the side clearance of the connecting rods. Blow compressed air over the oil holes to remove any dust. Coat the mounting bolts with Loctite LT2. Install the piston cooling nozzle, checking that it does not interfere with the piston. Check that the crankshaft rotates smoothly. Install the gasket using a guide stud. Install the gear case. After coating the cam bushing with engine oil, turn the camshaft backward and forward while pushing it in. Take care not to damage the bushing. Install the small idler gear. Install the shaft by aligning the oil holes, and install the gears by aligning the match marks of the gears to be assembled. Install the oil pump. Install the fuel injection pump drive unit. Be careful of the O-ring, as it is easily cut. Install the thrust plate with the edge turned upwards. Install the fuel injection pump drive gear. Install the large idler gear. Using a guide stud, Align all the gear match marks to install the idler gear. Check the match mark of each gear and the tightening torque of each bolt. Measure the backlash and end play of each gear. Refer to the shop manual for standard criteria. Install the gear case cover. Thinly coat adhesive agent to the gear case and install a gasket to the case. Prepare the special tool and install the front seal. Simplified tools other than this tool are available. Fill the space at the front seal to halfway with G2L1 grease. Thinly apply liquid gasket LG4 to the peripheral portion and then press fit the seal. At this time, do not apply grease to the dust seal lip surface. When the lip working surface of the crankshaft is worn, use the sleeve and oversized seal introduced in the service news. Install the flywheel housing. Thinly coat adhesive agent to the block and install a gasket. Use a guide stud to mount the flywheel housing. Check the difference in level between the cylinder block and housing. Insert the rear seal. As with the front seal, fill with grease and coat the peripheral portion of the seal with lubricant. Prepare the special tool to press fit the seal. Simplified special tools other than this tool are available. Install the flywheel using a guide stud. Coat the bolt with engine oil and tighten it to the specified torque. Measure the radial and face runouts of the flywheel and flywheel housing. To eliminate any error caused by crankshaft end play, place the crankshaft at either the front or rear before measurement. This is the measurement of the face runout of the flywheel housing. Measure the face runout at 8 points on the circumference and check that the total indicator reading is within the specified limit. Shown here is the measurement of the radial runout of the flywheel housing. This is the measurement of the radial runout of the flywheel. And here is the measurement of the face runout of the flywheel. Install the cam follower. Align the shaft with the dowel pin to install the cam follower. Mounting bolts are the special bolts with oil holes. The lower 4 fitting bolts of the cam follower cover are fitted with seal washers. The upper 2 bolts differ from the 4 lower ones in tightening torque. Mount the damper and crank pulley. Find the top dead center of R1 piston and check that the pointer aligns with damper R1 top. This is the valve assembly of the cylinder head. Coat the valve stem with engine oil so as to insert it in the original position. Install the valve spring guide and insert the spring. The smaller spring pitch portion should face downwards. Install the valve spring retainer and insert the cotter. Use a valve spring pusher to assemble the cotter. Tap the valve stem with a copper hammer to check that the cotter is inserted securely. Clean the cylinder head mounting face of the block to mount the head gasket. Check that the grommet and ferrule are securely installed and that no foreign matter is left in the cylinder. Then, mount the cylinder head. Coat the bolt thread and head portions with molybdenum grease. Insert the bolt and tighten it. Tighten the bolt to 15 kilogram meter the first time and to 22 kilogram meter the second time. The tightening order of the bolts is as follows. Tighten the bolts to an angle of 90 to 120 degrees. And then punch a mark on the bolts. The bolts should be replaced after 5 marks. Coat the crosshead sliding surface with engine oil to install the crosshead. The crosshead is adjusted as follows. Loosen the lock nut, return the adjusting screw, screw in while pushing the crosshead with one hand, tighten the screw to 20 degrees after it touches the valve stem, and then tighten the lock nut. Install the O-ring in the nozzle holder. Install a new gasket in the nozzle. Install the O-ring on the rocker arm housing. Thinly coat adhesive agent to the O-ring to prevent it from falling out. Install the gasket. Mount the rocker arm housing. Coat the push rod with engine oil and insert the rod in the cam follower socket securely. Coat the rocker arm with engine oil and install it. Install the rocker arm shaft, turning the wider surface downwards. Misassembly of the rocket arm shaft closes off the oil hole, which may result in engine seizure due to insufficient lubrication. Assemble the nozzle holder. Check that the O-ring and gasket are installed. Align the holder connection hole. Screw in the holder and align the connection with the nozzle holder mounting hole. After the holder bolts are tightened, tighten the connection to the specified torque and then tighten the lock nut. Adjust the valve clearance. Rotate the crankshaft to locate R1 and 6 top. Check that the number 1 valve appears while holding the number 1 and number 6 valves. Loosen the lock nut and return the screw. Adjust the exhaust valve to 0.8 millimeters and the intake valve to 0.43 millimeters. Assemble the aftercooler core with the welded side upwards. Coat the water pipes with grease and install them. Install the oil cooler. Install the water pump. Install the fuel injection pump coupling. Temporarily attach the bracket, mount the pump, tighten the mounting bolts, and then tighten the bracket bolts. Align the mark of the coupling and tighten it to the specified torque. Install the right bank governor rod. Check that there is no strain on the connection rod bearings. Install the left bank pump. Install the left bank governor adjusting rods. The right pump draws the rack out to the maximum, while the left pump draws it in to the maximum. These are the non-injection positions for the left and right pumps. Assemble the governor rods while maintaining these positions. Fine-tuning is required at the stage of the engine running in. Mount the exhaust manifold. Be careful when installing the gasket. Coat the thread and washer portions with molybdenum grease, which serves as a seizure prevention agent. Because they are special bolts, take care not to over-tighten them. Mount the turbocharger. Mount the aftercooler. Thinly coat the gasket with adhesive agent to prevent it from falling out. Then, tighten the bolts to the specified torque. Mount the turbocharger inlet connector and the air compressor. Check that the breather O-ring is securely inserted. Mount the fan belt and tension pulley. Install the alternator and adjust the belt tension. Install the oil filter, the fuel filter, the main relief valve, the O-ring, and then the oil suction pipe. Install the oil pan gasket. Coat the gasket joint with liquid gasket. Likewise, coat the joints of the block and flywheel housing, gear case, and case cover with liquid gasket. Perform a final check before mounting the oil pan. Mount the oil pan. Install the engine on the stand. Place the engine on a test bench. Connect the flange to the flywheel and center the engine on the test bench. Adjust the vertical direction of the engine stand to set the eccentricity of the engine and dynamo test stand within 0.13 millimeters at full runout. Incorrect centering causes damage to flange joints, oil seals, and thrust bearing. Connect the inlet piping for the coolant. And the outlet piping for the coolant. Connect the deaeration hose to the thermostat housing. Prime lubricant engine oil from the oil filter mount section and force oil to each portion. Add the specified amount of oil and check the oil level with the dipstick. This video features forced lubrication from outside. But when this unit is not equipped, lubrication to the turbo bearing and filter is required. Connect the fuel line. Bleed the air from the fuel filter. Install the wiring for the starting system and the exhaust butterfly valve. Mount the exhaust pipe. And the air cleaner. Install the tachometer drive unit and tachometer. Mount the exhaust temperature sensors to the inlet and outlet of the turbocharger. Attach the air boost pressure gauge to this tap hole. Install blow-by measurement tools and connect them to the pressure gauge or the U-tube, which uses the difference in levels of the two columns of water. The tool is to be mounted on each bank, and the tool on one side is covered by tubing. The air outlet temperature of the aftercooler is measured from here. Install the air intake pressure gauge and air intake temperature sensor. Install the exhaust back pressure gauge. Install the engine oil temperature gauge and the engine oil pressure outlet. Adjust the fuel injection timing. The injection starts at a position before 30 degrees top dead center. Check that the parts number of injection pumps are suitable for each model. Align the pointer with the damper mark to a position before 30 degrees of the L16 top. Then, remove the L1 injection pipe, delivery valve, and springs. Then, assemble the delivery valve holder. Tighten the holder to the specified torque. Return the crankshaft to this side by 30 degrees and rotate it slowly in the clockwise direction. Operate the priming pump and check the pointer and damper line at the time when the fuel flow stops. When the position before 30 degrees of the L16 top is confirmed, injection timing is correct. At the same time, check that the stamp mark on the injection pump matches. When the injection timing is incorrect, loosen the flange bolts of the pump coupling and rotate the flange to a position where the fuel flow stops. Install the delivery valve and springs in the former positions and tighten them to the specified torque. To check for leakage from the fuel inlet of the cylinder head, remove the rubber cover. The connection flange features a slit to permit fuel leakage to be checked. At the non-fuel injection position, perform cranking operation until the engine oil pressure rises. At this time, do not rotate the starter continuously for more than 20 seconds. Perform the engine run-in operation. Refer to the service menus for running in conditions. During the run-in operation, look for assembly error or oil leakage at each part. Also, before starting the performance test, perform fine adjustment of each part so that it is in the optimum condition. While performing the run-in operation, the following items should be measured. In the performance test, if the engine performance is not specified, the following items are required for troubleshooting. Adjust the injection amount of the left and right fuel injection pumps. Use the left pump adjusting rod while watching the change in exhaust temperature due to the difference in the injection amount of the left and right pumps. Because the injection pumps of both banks are linked, and only the left bank governor controls the injection amount of both banks, the injection amount must be adjusted. For the WA800-2 and D475A-2, set the exhaust gas temperature of the right bank at 10 to 30 degrees lower than that of the left. This adjustment is necessary for the exhaust gas colors from both banks to be uniform. For the HD785-3, adjust the exhaust gas temperature from both banks to within plus-minus 10 degrees. The exhaust gas temperature of both banks can, as illustrated, be adjusted by rotating the adjustment rod. Now, start the performance test. When the results of the performance test do not satisfy the standard values, refer to the service news and testing method. Replace the nozzle tip, the turbocharger or the aftercooler, and check the running condition. Then, conduct the performance test once again. Finally, check to see if all the bolts of each part are properly tightened, that no interference from wire harness or hoses occurs, and that there is no oil or water leakage. This has been the introduction of the key points of overhaul for the sa12v140 engine. For actual maintenance work in the future, refer to this video, the shop manual, and the service news.